Hello, everybody, and welcome to Talk Nerdy. Today is August 10th, 2020, and I'm the host of the show, Cara Santa Maria. And this week, we've got a great chat coming up for you. But first, I want to thank those of you who continue to support the show week after week. If you want to pledge your support or just learn more, you've just got to visit patreon.com/talknerdy. This week, I want to thank Mary Neva, Michael Gaucher, Brian Holden, Charles Payette, David J. E. Smith, Dudas Infinitas, Ulrika Hagman, Pasquale Gelati, Daniel Lang, Christopher Pitts, and June Sapara. Thank you all so very much. And don't forget to stop into the Talk Nerdy shop. The URL is talknerdymerch.com. Even though I'm out and about right now, I'm not home, I can still get those objects and items shipped out to you. All right, everyone. Who are we talking with today? None other than Dr. Helen Pilcher, and she had quite the journey. She went from a PhD in cell biology to a stand-up comedian, and now she's a freelance science writer. She's written for BBC Wildlife, The Guardian, Science Focus. She was a reporter for Nature in the past, and her most recent book is called Life-Changing: How Humans Are Altering Life on Earth. How are we altering life on Earth? I guess you got to stick around to find out. Without any further ado, here she is, Dr. Helen Pilcher. Well, Helen, thank you so much for joining me today.
You're very, very welcome. It's lovely to be here.
All right, so I can sense by the accent and by the time difference that we are connecting from across the pond, are we not?
We are. I'm based in the UK. I'm in the centre of England in a very green, leafy area called Warwickshire.
Oh, I love that. How hard has your region been hit? Are you guys in lockdown? Is everybody wearing masks, or is it pretty open where you are?
We have been in lockdown with the rest of the country, and we've been easing our way out of lockdown. But very close to us is a large city called Leicester, and they've just been locked down again, like Melbourne has in Australia. So, you know, the threat of COVID is never far away, I think. But we're all good here.
Right. That's good to hear. That's good to hear. So same kind of in Los Angeles, big city, obviously continuing to deal with it. I think did some smart things early on, but even with those types of restrictions, this virus is a bugger, so it works its way through.
Yeah, can say that again.
Yeah. Well, I'm really excited to be talking with you about your new book. We've had to reschedule a couple of times, so I'm super thrilled to finally be able to chat with you, even though it's been out now for a few months. The book is called Life-Changing: How Humans Are Altering Life on Earth. So really what we're going to be talking about, right, is the sort of interplay between our activities here on this planet and how they are affecting all sorts of life forms kind of from an evolutionary perspective.
I mean, that's right. My background is that I was a scientist for a long time and I worked in stem cell biology, but I've also been really interested in the natural world all of my life. And a little while ago, I wrote another book called Bring Back the King about de-extinction. And de-extinction is the ability of scientists to bring extinct species back to life. And that is a technology that is being developed at the moment. And that book looked at everything from projects trying to bring back the woolly mammoth to projects trying to sort of selectively backbreed the ancestor of modern cattle. And there are some pretty amazing projects that are out there. And it got me thinking, you know, wow, if we have the technology at our fingertips to, in theory, bring back the woolly mammoth or the passenger pigeon or the thylacine, what else are we capable of? And that really was the sort of motivation for the new book, Life-Changing. And I wanted to think about, you know, de-extinction is one very, very extreme way that we are altering the evolutionary process. But the more you look, the more you realize that actually we've been tinkering with evolution as a species for a really, really long time. And it's not just the showstoppers like the woolly mammoth. Looking out of my window, people don't realize it, but we're actually surrounded by species whose evolutionary fate we have been changing and continue to change right now. So sort of like the fingerprints of our activity are all around us.
Absolutely. And I mean, it really does bring up not just the like basic questions about feasibility and about the actual technical and logistical components of the scientific efforts going into them, but of course, these massive ethical quandaries. And that's, I think, in some ways where I want to start, but ultimately will probably end as well. Before we get into the brass tacks of all these different species and all of these like incredible scientists who are working on these big problems, I would love to know from you personally in doing all of this research, and of course, just as your previous work as a scientist, how do you feel? Because I think this encapsulates a lot of what you write about in the book. How do you feel about zoos?
Oh, wow. Okay.
Right?
I
It's a
have,
complicated question.
yeah, I have really mixed emotions about zoos. When I was much younger, it was very black and white for me that zoos were wrong, that zoos were prisons for animals that really deserved to be in the wild. But I think as I've got older and the world around me has changed, that view is not so clear cut anymore. I can see as a parent that they play a phenomenal role in nurturing the next generation to care about the environment. But arguably, just as important, zoos and wildlife parks are becoming, sadly, the last refuge for many species that have nowhere left to be in the wild. And zoos play a really vital role in breeding endangered species. And there are projects out there where species have been returned to the wild, and endangered species that once were on a nosedive towards oblivion are now taking an upturn because of conservationists who launched breeding programs to bring them back from the brink. So I think it is a really, really complicated and ethically charged issue. But I think the sad reality is that, you know, we do need to look after these species that we are pushing to the brink of extinction, and that zoos and conservation initiatives play a really, really important role. How do you feel about zoos?
I think that's a very kind of similar view. The more that I've read about zoos as I've gotten older as well and done more research, the more that I realized that kind of in the beginning of the existence of zoos, at least here in the United States. I'm not sure how similar this is in the UK, but they really did start as kind of like it was circus law, and so there were a lot of really unethical practices and a lot, just, you know, zoos at the beginning of their existence were much more, as you described them, kind of like sideshows with animals. And then as scientists began to realize, and not just scientists, but community members began to realize the effect that we've been having on the planet, we began to realize that it's really an ethical imperative to develop these breeding programs and to, you know, do the important conservation work that sometimes, unfortunately, you can only do in a zoo. Or I like that you also mentioned wildlife refuges because refuges, because I think a lot of people don't think about that in the Western world so much. I think people who have never spent time in Africa, for example, don't realize that the vast majority of these areas where we think of as being really rich with a lot of biodiversity, especially with large animals like big game, the big five, are mostly existing in these managed regions. We think of everything out there that's not home as being wild, but really most everything on the planet now is managed in some way or another, isn't it?
I mean, that's right. And that was one of the big themes that emerged from researching this book, is that we are now influencing the evolutionary fate of all life on Earth because of our collective global actions. And we're seeing evolutionary rates speeding up. We're seeing extinction rates speeding up. We're seeing population declines in species that were previously thought to be bulletproof. And this is our doing. And it's interesting because I think zoos have realized in recent times that they have a responsibility to protect the species in their care. And one of the big take-home messages for me researching the book is that as a global community, I think we need to feel the same, that we have, if we are responsible for these sweeping and global changes, we've somehow become zookeepers or museum curators, if you like, for the species that we share our planet with, because we are responsible for the changes that they are facing, the challenges they're facing. We're changing the world so quickly, many species just can't evolve quickly enough to keep up with the pace of change. And I think we have a responsibility to act kindly and cautiously and caringly towards these species, for their sake, but also for our sake, because, we're fools if we think we can't live without nature. And we're seeing, for example, you mentioned the big five in Africa. We're seeing, there are currently 2 northern white rhinos left, just 2 of this particular species or subspecies. And I don't feel good about that at all. And this is a species that was pushed to the brink through because of human activity, because of conflict, and because of poaching. And in that case, it's really interesting because traditional conservation methods have sadly failed the northern white rhino. So we find ourselves in the situation that we're in. However, again, something else that I learned about in the books that I've written is that we're seeing this new kind of hybrid breed of conservation emerging, which is really exciting. And it's based on sort of like the bedrock of conservation, looking at anti-poaching strategies and habitat management. But it's supplanting these ideas with new high-tech methods. So we could just give up on the northern white rhino and say, okay, we've only got 2 females left. It's game over. These 2 beautiful, amazing animals are walking dead. They're ghosts. That's it. And this is what's happening, thankfully, we have scientists who are doing cutting edge science, trying to secure this species a brighter future. So they have semen samples frozen away from some of the last surviving males before they died, and they are collecting eggs from the last 2 remaining females who have health problems and who can't carry baby rhinos by themselves. And they're actually trying to create test tube rhinos, so IVF rhinos in a dish. And then the idea is that when the little embryos start to develop, they would implant them into the uterus of a closely related species of rhino. And in this way, we could bring the northern white rhino back. So I've gone off on a massive tangent, but, I think we have this responsibility to protect the natural world around us. And even when we think things have gone so desperately wrong that a species is practically extinct, like the northern white rhino, science and technology, I think, give us hope that we can turn things around. And, rather than there being no northern white rhino for my children or grandchildren to see in the future, maybe we don't have such a bleak end to that story. Maybe we can use technology and science and what we've learned about manipulating the evolutionary process across the decades to try and do something positive. And I think that's really exciting.
Right. I think a lot of times when you really look at the crux of this problem, you see strong opinions across the board. And I think that, coming back to that like core ethical question, especially around your previous book, talking about de-extinction, one of the important concepts, actually the important concept that maybe sometimes gets lost is that the reason these conversations are on the table is not because those species were passively lost, but because we have very good evidence to support the not even argument, but the strong scientific theory that the reason those species were lost is because of our own action. So is it incumbent upon us to save them if they're on the brink, but even beyond that, potentially even bring them back if we have the technology to do so? At this point, it's true, right, that almost nothing on the planet is not affected by our just intense and wide sweeping action and activity. Like the human, even if you live in a city, your activities are touching the most remote species in the most remote places. There's garbage at the Mariana Trench, there's deforestation happening in the deepest parts of the Amazon. Like there's nothing that's untouched at this point, is there?
Well, I think you're absolutely right. I think there might be some microbe dwelling deep down in, 6 meters down in the ice in Antarctica or the Arctic that is blissfully immune to the onset of human activity and global change.
Right, until their ice melts.
Exactly,
unfortunately.
Right? So it's not going to last. And what we are seeing now is all species being impacted by the actions of humans. And we're seeing that in a lot of different ways. I mean, as we've touched on already, we're seeing extinction rates soaring. So there is, and I don't pluck these figures out of the air. These are from really rigorous scientific research. But scientists now estimate that extinction rates are 1,000 times higher than during pre-human times. So, it leads to the inescapable conclusion that we're doing something here. We lose between 30 and 150 species every day. And because we barely got around to describing a fraction of the species on our planet, we don't even notice most of this loss that is ongoing around us. And I mentioned population declines, extinctions are the end point of loss. But what's particularly concerning now is the population declines that we are seeing. So this is kind of like where you're halfway down the mountain towards the bottom. And we're seeing populations of invertebrates. In my lifetime, we've seen a 60% decline in insects in Europe. And that's something I relate to very personally because I'm very much a bug lady. I enjoy my butterflies and my moths. And when I was a kid, I remember being able to walk past the butterfly bush in my garden and nudge it, and there would be this cloud of butterflies that would emerge from it. And it was just a joy to watch. And I have a similar plant in my garden today, and I'm lucky on a summer's day if I see a single butterfly on it. And I live in a very similar area. So we're driving these to extinction. But the other thing that's really, really interesting is when there is persistent and intense environmental change, so through things like climate change and pollution, as you mentioned, things react by evolving. So what we're actually seeing now, as well as these extinctions, is the flip side of evolution, which is species are going extinct, but we're seeing the species that can adapt to environmental change are doing their damnedest to do that. So wherever you look, you see evidence of evolution speeding up. And when Darwin came up with his theory of evolution by natural selection, he imagined that species would evolve slowly over these kind of achingly long geological time spans. So he imagined it would take new species maybe hundreds of thousands or millions of years to evolve. And that's certainly backed up by the fossil record at different points in the history of the world, of the Earth. But what we're seeing now is that new species are evolving more rapidly. And what we're seeing and what scientists are documenting is this rapid environmental change. So sitting talking to you now, looking out in my across my garden in sort of rural, green and leafy central England, I have like a row of bird feeders that are hung up for the little garden birds. And one of the things that scientists have noticed is that great tits, which are like a tiny little songbird that we have over here, I don't know if you get them in the States, they're evolving longer beaks. And they're evolving longer beaks because it helps them take the peanuts out of bird feeders. And this is a change that's been documented in the last 20 or 30 years. And the more you look, the more you see evidence of this rapid environmental change. So in Nebraska, there's a lovely little bird called the cliff swallow, and it makes its nest sort of in the underside of bridges and close to roads. And it didn't used to do that when there were no bridges and roads around. So it's kind of adapted its behavior. But as a result, what we're seeing is that its wingspan is changing. So over the last 40 years, this bird has evolved and its wings are now about half a centimetre shorter than they used to be. And the scientists think that the reason for that is because when they're out catching insects on the wing, they have to dodge traffic now. Now, they never had to do that before. Wow. And if they have shorter wings, they can kind of dodge the blunt end of an SUV much more successfully. So the birds with shorter wings have the advantage, the fittest survive according to natural selection. So we're shaping the evolution of this particular species just by building roads. And there are tons of wonderful examples like that. But of course, this only gets us so far. We will see species adapt and change. We will see new species evolving. But many species reproduce too slowly and they can't keep up with the pace of environmental change. So the winners in this kind of genetic lottery will be the smaller, fast breeding, more genetically varied, adaptable organisms. And the losers, and this is what we're seeing, will be the larger, slow breeding organisms, your northern white rhinos, your African elephants, which don't stand a chance of being able to adapt quickly enough to this. We're changing the environment on such a scale at such a pace. We're not going to see an end to life. What we're going to see in 1,000 or 10,000 years is a world that looks really different. So we have there's this background rate of extinction that people realize extinction is something that happens all the time. But if you look back across the history of life on Earth, there have been 5 periods where there were periods of mass extinction. And during a time of mass extinction, vast quantities of species die and disappear in geologically small and insignificant time periods. So the last mass extinction, the 5th mass extinction, was 65 million years ago, famously, when an asteroid slammed into the Earth and put an end to the dinosaurs. 65 million years later, we don't have an asteroid heading towards the Earth, but we have climate change, we have pollution, we have habitat destruction, we have invasive species moving around the globe. We have all these things. And the collective output of that is that we are now living through a time of mass extinction where many species are disappearing in a geologically trivial amount of time. And future geologists who look at the fossil record and look at the rocks that were laid down round about now are going to see this period of significant change when the makeup of life on Earth changed. And that is something that we're responsible for. And, we need to be pretty careful about about what we're doing. I will let you get a word in edgeways, but just this final thought. 10,000 years ago, when we were just beginning to domesticate farm animals and crops, so 10,000 years ago, if you were to go out and round up all of the large land-living vertebrates on the Earth and weigh them, which is quite a task, I know, but if you were to do that, 10,000 years ago, you would find that 99% of that biomass was wild animals. Now, if you were to do the same thing today, you would find that 4% of that biomass is wild animals. And here's the thing, the remaining 96% is humans and the domestic animals that we have created. So we're now seeing that the vast majority of kind of living stuff on the planet are these domestic creations. So chickens, cows, pigs, goats. And it brings us back to the beginning of this conversation, because these are all species that we have, whose evolutionary future we have tampered with on a massive scale. We have created animals that are unrecognizable from their predecessors, and we've done it to suit our needs. So the global change has been absolutely phenomenal.
Right. And very likely those domesticates would have no potentiality if not for kind of the keeping by humans. Like, we can't release our dogs into the wild. I mean, they may go feral, but definitely the cows and the pigs and the chickens. Maybe if we suddenly cease to be, they would be able to re-inherit. But there is a good argument for the fact that they're domesticates for a reason, and they may not be able to persist as, quote, wild animals, which is such a I mean, gosh, 94%. Like, that's a big change. That's incredible. And that's something that I don't think we often think about when we think about those sheer numbers. Lots of times when we talk about mass extinction, or we talk about organisms being at the brink of extinction, and we kind of compare the background extinction rate to this kind of human or Anthropocene like induced rate, those numbers are hard for us to make sense of. When we're talking about species in the thousands, and like you were talking about earlier, just the insects. Where are the insects going? I remember when I was a kid playing in the front yard, and there would be what we called lightning bugs, fireflies everywhere. I don't remember the last time I saw a firefly.
And isn't that sad? I think that's such
so
a sad thing, and that they're not there for the next generation unless we do something about it. And the critical point here is, a lot of people don't like insects and don't like bugs, but we can't live without them. If we want pollination, for example, they're pretty important. If you like chocolate, you need bugs. Chocolate's pollinated by flies. The natural world is not just nice to have and good for the soul, although that is, two really important reasons why we should protect it. It also provides us with this wide range of ecosystem services that we can't live without. It gives us the food on our table. It gives us clean water. It helps us to, the natural world. We have decomposers, we have predators, we have herbivores, we have dam builders, we have water purifiers. We have this huge range of incredibly important roles that are fulfilled by species living in the natural world. And we are fools if we think we can live without it. We take these things for granted so readily because we've become so dissociated from food. It's just something we can buy in the shops. And people don't realize how intimately connected our well-being and our future is to the natural world around us. What's really interesting as well. So, as mentioned, 10,000 years ago, our ancestors started domesticating wild animals. So there was an amazing animal called the aurochs, which was this muscular, big-horned cattle type animal that we turned into the domestic cow. We turned the wild boar into domestic pigs. I mean, along the way, we added a couple of extra vertebrae, which most people, don't realize. If we'd done that through genetic engineering, there would be outcry, but we did it through selective breeding. So, we changed pigs we made them longer. Chickens, we have, changed beyond all recognition from their ancestor. And now we end up at a point where we have 70 billion domestic farm animals on the planet. And in a sense, you could look at this and you could say, this has been a major success story. Well done us, well done humanity. We have, by domesticating animals, we paved the way for the rise of civilization, which is a very reasonable argument. When we started domesticating animals, we fueled the rise of trade. We were less tied to the land. We were able to give good nutrition to our children. It fueled the rise of trade, of cities. And we fast forward now, and we live in this very developed world where food is plentiful. We're no longer hunter-gatherers. We haven't been for a long time. But the flip side of this, and what a lot of people don't realize, is that 2/3 of these domestic animals, domestic farm animals that we've created, now don't live on the land and, rootle for insects or rhizomes, or they don't graze naturally in a field. They're shut away in factory farms, and they're being industrially reared. And that has all sorts of problems associated with it, not just from an animal welfare perspective for the domestic animals that we've created. But what we're seeing now is pristine wild habitat on one side of the world being, flattened to make way to grow the crops that we need to feed these industrially reared animals. And this is becoming a significant problem. So on the one hand, we created these amazing animals that keep the planet well fed. But the flip side to this is that we're now destroying the natural world in the process. And we're seeing a third of the world's cereal harvest, 90% of the soya meal that we grow, and 30% of the global fish catch going to feed factory farmed animals. And as a result, we're seeing pristine rainforest in places like Indonesia that are being bulldozed, and lots of species that I'm not sure we could ever bring back are being pushed closer to extinction because of the way we produce our food. So on the one hand, we're shaping the evolutionary future of these wild animals by pushing them to extinction. On the other hand, we've shaped over the last 10,000 years the evolutionary future of these domestic animals that we've created. But now the two are sort of colliding and creating problems that will come back and bite us on the backside very, very rapidly unless we do something about the way we look after the natural world and the way we produce our food. I think it's been estimated that if we were to return all of these animals to pasture and give the cereals and the grains that we're currently feeding to these animals to people instead, we'd be able to feed an extra 4 billion people on the planet. So it's not that we don't have the resources to feed our planet properly, it's that we've slightly messed up the way that we're doing it.
Well, yeah, we use them really inefficiently. Like you said, the grains and the cereals, so like the corn and the soy, the wheat that we're feeding to these, what we think of as like larger farm animals, those are calories. So they need these calories to eat them in order to convert them into muscle mass, and then we slaughter them and eat their muscles. And I think an even more striking example, as you mentioned, is that people, at least in the Western world, tend not to be that interested in eating small, oily fish, even though they're like packed with nutrition. And so there's these huge feed operations where we're overcatching these small, oily fish halfway across the world and then shipping them to fish farms in order to feed the salmon or the trout or, the fish that are more palatable to kind of like Western consumers. And then we're eating those fish, which is like just really inefficient use of these calories. And so, like you said, the food is there, but we're feeding it to the food. Exactly. And then we're eating the food, which is very strange. And it leads to, not just one thing that you didn't mention, but I know that we would get to, is that it's not just about overfishing or about over harvesting and not having this grazed land anymore, having this horribly just barren land where no insects can even thrive. But it's also the fact that in keeping so many domesticates in such close quarters, because it's really the only way at this point that we can feed such a growing population is to factory farm on this industrial scale. Now, all of a sudden, we're having these consistent spillover events of harmful viruses and bacteria. I mean, that is what coronavirus is. This is a virus that was in an animal, and then it spilled over to humans, and we didn't have any defenses for it. It was completely novel, and our bodies had no idea what to do with it. And most big plagues and pandemics, that's how they occur.
I mean, you're absolutely right. I mean, what we're seeing here is that the way that we are producing our food has now become the second biggest driver of biodiversity loss after overexploitation and habitat loss. But there are these other effects too, and we've learned the hard way about this in the last 6 months. So nobody's exactly sure what the original source of the coronavirus was, but it came from an animal. We can tell that by tracing the genetic sequence and looking at similarities between the strain that is infecting humans and the strains that are found in wild animals. And the current thinking is that this emerged probably in bats, maybe jumped to a second host via something like pangolins, potentially, is one of the ideas that I've seen out there, before infecting humans. But the problem is when we keep factory farmed animals in really close confines, we create the perfect storm for viruses to mutate and evolve. And then they spill over into humans. And also with factory farming, of course, as I said, what we're seeing is this destruction of wild habitat. And what we're seeing there is wild animals with the viruses that they harbour. And I should say these viruses generally don't harm the animals that, are the hosts for them.
Right. So they're just reservoirs. So they safely, spread them all around and not making them sick.
Exactly. And when these animals are in the middle of a rainforest that is big and human settlements are far away, they pose us very little threat. But when we start eroding that habitat for whatever reason, including to feed factory farmed animals, we see more wild animals becoming concentrated into smaller and smaller spaces. And those wild spaces become in increasing proximity to humans and cities and towns. And then you are just pushing these hosts, these reservoirs of disease closer into contact with humans. And we're seeing the opportunities for disease transmission increasing. And now people have been warning about this for a long time. And what I hope, at least, if some good can come from the terrible tragedy that continues to unfold all around us with coronavirus now, it must be that we learn to respect nature. And certainly over here, what we're talking about in the UK is trying to build some kind of green economy off the back of this, where we prioritize nature and the services that it brings alongside the traditional kind of measures of economic growth. And I know the politicians, they talk a lot of talk. I would really like to think that is something that is going to change off the back of COVID-19 and the trauma that we've been living through. But only time will tell. But yeah, as we erode the natural world, as we rear our domesticated animals intensively, we increase the risk of future pandemics. And that is the sad truth of it. So we need to think, like I said, we need to be curators of the natural world and the inhabitants in it. And we need to think carefully about how we manage this planet, because it has limited resources. And it has a nasty sting in the tail sometimes when viruses spill over into the human realm.
Right. And I mean, it's unfortunate that probably the main motivator for affecting change and for like putting our money where our mouth is ultimately not an altruistic one. It's ultimately a very selfish one. Like, how does this affect me? Am I at risk? Okay, maybe I'll pay for something, as opposed to really understanding the balance, trying to really understand that we've got to be thinking 10 chess moves ahead. And it's not just, okay, I'm already in checkmate. But that really does seem to be a real shortcoming of the human spirit, or at least maybe the political side of humanity, which is that unless we feel the burden from our own actions, it's very hard to make decisions that will have outcomes, decades or hundreds or even thousands of years in the future. We're thinking about the next, at least in the US, we're constantly thinking about the next 2 to 4 years. That's how all of our politicians act.
But I think we are desperately short-sighted as a species,
right.
and particularly when it comes to the natural world, and so we don't think ahead. And the other thing is that we very rarely, so we have this history of modifying animals that goes back 40,000 years to when we first started domesticating the dog. This was the first animal, from the grey wolf. This was the first animal whose evolutionary fate we changed significantly. And since then, everything that we have done in terms of manipulating the animal kingdom has pretty much been for our benefit. It's all been done for us. So we created farm animals because they helped to feed us. They were useful beasts of burden. In more recent years, we have started selectively breeding animals on a whim. So, you can have wonderful long-haired guinea pigs, and you can have fancy goldfish with sort of fancy fins and almost like great big Elvis-style quiffs. And then we've selectively bred for behavior. Again, not behavior that is useful for the animal, but behavior that has suited us. So, I currently have my little genetically modified wolf sleeping at my feet, my pet dog. And I'm not complaining, but of course, we have selectively bred dogs to be our companions, to be docile, to be aggressive, to be guard dogs. But when you start looking around the animal world, you realize, as I say, that we've done this on a whim with very little thought for the animal's well-being.
Right.
There's a wonderful strain of pigeon, so another domestic species called the Birmingham roller. And Birmingham is a big industrial city not far from where I live. And this strain of pigeon was created through selective breeding in the last sort of 100, 200 years. And what this bird does is it takes off and it flies up into the air like a regular pigeon. And then, for no reason at all, it suddenly seems to fall from the sky, and it starts doing these backward somersaults as it falls from the sky. And you watch these birds and you think, oh my God, it's going to hit the ground. This is game over for this pigeon. And then as they head towards the ground, and just when you think it's too late, they pull themselves out of this spinning nosedive. And they take back off into the air. Now, there is no evolutionary advantage to this behavior. There would have been some mutation or series of mutations that cropped up over the years. Breeders noticed that this bird had this quirky behavior. They thought this could be really interesting. So they started selectively breeding these animals together, and they made the behavior more profound. So what you've ended up with now is a fancy strain of pigeon. But if you think about it, these birds are far more prone to raptor strikes. They're far more likely to be taken from the air by birds of prey, and sometimes they suffer from spinal injuries when they don't judge the drop correctly. So, we have really selectively bred and used, by and large, the sort of modern tools of genetic editing and genetic modification to alter animals for our benefit. And we do that, and sometimes we've been quite pathological with what we've done. So again, if you look at dogs, for example, there are many breeds of dogs that have these congenital health problems. Now, if you were going to suggest that somebody was going to genetically modify a dog in the lab so that it had a really wide skull, so that its skull was so big it could never be born naturally and it could only be born by C-section, and not just that, we would genetically modify this dog so it had this really flattened snout, so it had like a really sort of flattened face, because it might look good. I mean, the dog might struggle to breathe, right? And maybe it would have these huge folds of skin around its head, which would sort of wobble when it walks along, and it would look great, but they might get infected sometimes, right? If I told you that scientists were going to make an animal like that in the lab, everybody listening in would go, that is outrageous. Well, that is the dog breed, the English Bulldog, and that is what we have created through decades of selective breeding. And we did that for our benefit because we liked what we were creating. We never thought about the health of the animal that we were creating. And I see this again and again in the sort of domestic farm animal area. You see chickens are a remarkable example. So the chickens that we sort of classically use for meat production now are really a very recent invention in the last kind of the last 50 or 60 years. And they were a product of selective breeding and of crossbreeding. But what we've seen in the last 60 years is that 60 years ago, it would take a little baby chick about 16 weeks to grow up and get to the point where you wanted to pop it in the oven. But they now do that in about 4 weeks. And in the same period of time, in that 60-year time span, we've seen the weight of the average chicken that you use for the pot, we've seen it double from about 1 to 2.5 kilograms. So we've sped up their growth and we've made them bigger. And this takes its toll on the birds. So you have these puffed up birds in factory farms that have mobility problems. They have circulatory problems. They're prone to heart defects and respiratory problems. But because we kill them really quickly, nobody really seems to mind. So again, we've been blindsided and we've changed animals for our benefit very often with this kind of blind spot when it comes to animal welfare. And one of the things that writing the book got me thinking about is we really need to think about altering the evolutionary fate of animals not just for our benefit for the future, but for the first time, we need to think about doing it for their benefit too. And it sounds like a really obvious thing to say, but it's not something that's been done. Even when you look at the history of genetic modification in the lab, where people have been deliberately moulding the DNA of species in the lab for various different reasons, it is almost entirely done for our benefit, for us as humans. It's to make new materials, it's to learn about disease, it's to produce drugs, it's to produce transplant organs. There are very few projects out there where this is about the health of an ecosystem or about the health of a species. Now, there are a few out there now that are emerging. So people are thinking about genetically modifying certain farm animals to make them too resistant to disease. And these are potentially good things. But again, we need to be really, really wary, because if we end up modifying, I don't know, pigs to make them resistant to certain viruses, that could be a really good thing, but not if it's used as a further tool of intensification, not if it means that we can continue to keep these animals at high densities in factory farms. And now it's one less disease that we need to worry about them catching.
So well, and of course, that's the whole purpose, unfortunately. I mean, that's ultimately what we know. We would do that if we were able to create an organism that withstood a certain type of pressure that ultimately, sadly, means, okay, good, then that pressure can be withstood. I mean, that's the point, right? And it's so dangerous. It's so sad. And it's exactly what you said. Like, previously, we were so concerned simply about how can we service ourselves better? How can we feed ourselves more without our food falling victim to disease? But now there is at least a sheen. I don't know how deeply it goes throughout society, but we're beginning to see a sheen of concern about the ecosystem as a whole, or about the welfare specifically of the organism. And this, of course, conversation has only really so far focused on animals. And like the vast majority of the genetic modification that we see in organisms is in plants, is it not? Like, at least when it comes to modification for human consumption.
Yeah, absolutely. And I mean, again, what's really interesting is actually this is something that's been going on for much longer than people realize. So, there is a lot of talk at the moment about a technology called CRISPR-Cas9, which is, I'm sure your listeners are familiar with it, a type of gene editing, which lets people go in and make very sort of precise changes to the genetic code of living things. But in fact, if you go back to the 1950s, we were genetically modifying plants on a really massive scale. There was something called atomic gardening, whereby, and this was done in various places around the world, it's not well known about, whereby you had a radioactive source of something like cobalt-60, and you'd have it in a plot in the center of a circular plot. And then you would plant seedlings going out in a circle from this source of cobalt-60. And the idea was that you would then blast the plants with cobalt-60, and this would cause random mutations to the plant's genetic code. And some of the plants that were really close to the source would just wither and die as expected. Some of the plants that were a long way away would experience no change, but somewhere in the Goldilocks zone, somewhere in the middle, some plants might actually gain some useful mutations. And in fact, many of the plants that are still being widely cultivated today are a product of this atomic gardening. So the mint that is used in a lot of people's toothpaste when they brush their teeth at night comes from a strain that was produced by atomic gardening. A barley that's commonly used in beer. There are strains of soybean, of sunflower, and people. It's very weird, but for me, I feel much more comforted if scientists are going to go in there and make changes to DNA carefully. But of course, in the past, we did it randomly. It was a really scattergun approach.
Right. Yeah, that's what I was going to say. It's funny that people are so much more comfortable with either selective breeding or, like you said, atomic gardening, which is like, it just sped up the process a little bit more, as opposed to waiting for the generations to change on their own and breeding them together. Let's force the generations to change, but still haphazardly. And yet there's a fear around transgenes, right? Around like more focused genetic engineering using something like a CRISPR-Cas9, where instead of changing 50,000 genes, we're changing 2. We know exactly what's going on. For some reason, that all of a sudden is playing God, or that is beyond the pale. And I've always really struggled with the idea that people, I think a lot of it is just fear of the unknown, but I've struggled with the idea that people are by and large kind of really against GMO food when they're perfectly fine with GMO by another name.
It's fascinating, isn't it?
Yeah.
I mean, in the book, I tell the story of there's a type of salmon that is on sale for human consumption in Canada. It's actually produced by an American company. And this salmon was actually produced, it was made over as a strain. It was made about 25 years ago, sort of using what today we would probably class as quite primitive GM technology. But the end result is that you end up with a fish that has the genes not just of one species, but it has DNA from 3 different species in it. So you mentioned transgenes, and a transgene is, when you take a gene from one species and you put it into another. And this seems to me where people start to get a little bit worried, which is really interesting, I think, thinking about this sort of as an argument. So we've got this salmon called the Aqua Advantage salmon, and it contains a growth factor from a Pacific salmon, which is a bigger fish. It contains another stretch of DNA from something called an ocean pout, which basically turns the other gene on. And so what they've created is a salmon, an Atlantic salmon that grows twice as fast as regular salmon. It eats 25% less feed, and it converts the food that it eats into flesh far more efficiently. Now, this has been on sale in Canada since 2017, and it's the first genetically modified animal to end up in the food chain anywhere. Now, I would argue that all of our cattle and all of our chickens are genetically modified. We just did it over thousands of years through selective breeding. But
Right.
obviously what we have here is something a bit more extreme, because we're moving genes from one species of fish into another species of fish. So that's something quite different. And what's really interesting, my mum is 80, and she was reading my book, and she read the bit about this transgenic salmon with the additional genes. And her response was, well, yuck, that's disgusting. And I said, well, why do you think that? And she said, well, it's just not natural, is it? And of course,
right.
On the one hand, you can argue that it's not natural. But on the other hand, you can make arguments that there are many hybrid species in nature which share DNA from 2 different species. Hybridization is rife in the natural world. Animals, ducks, butterflies, they're not that fussy. Life is about spreading your genes. And if you do that with a species that is not quite as genetically compatible as some would think, the natural world doesn't care. So we have hybrids out there naturally, and we do have instances where naturally one gene from one species has ended up in another. So sweet potatoes, we're cooking sweet potatoes for the kids tonight. They have genes from bacterium have ended up in their gene, and that quite naturally. So people find this idea unpalatable because they think it's unnatural. And on the one hand, it is, but in the book, I sort of use this term post-natural, because I don't think these fish are unnatural. Right? They're still made from the same biological building blocks that all living things are made of. We have this shared language of every living thing on the planet, which is DNA. But I think they're post-natural because they owe their existence to the actions of humans. And when I first started looking into the book, I thought post-natural would refer to animals that had been deliberately engineered. So GM animals, GM plants. And I thought it would probably apply to farm animals and domestic animals too, which it does. They've all arrived at their current incarnation because of human activity. But looping back to the beginning of the conversation, what I've realized now is that we are in a global era of post-natural activity, because as we said at the start of this conversation, our actions are changing the evolutionary trajectories of all life on Earth. So you could argue that none of it is natural, that it's all unnatural, because humans are the driving force behind all of this, or I prefer to think of it as a different type of natural, that humans have become this dominant force on the planet. And this is the result of our collective actions.
And some of it is, more passive, like it was maybe an unintended consequence. And some of it is completely active and directed, but I think for all intents and purposes, there really isn't much of a difference. I don't see much of a difference between, the salmon that has an ocean pout gene and the strawberry that everybody eats that is a cross between a strawberry, I can't remember, that grew in like Brazil and then somewhere in Europe, like two strains that never would have met in the wild. But of course, now that's what everyone eats, or the corn that people eat, which is unrecognizable compared to the maize from which it was sort of originally evolved. That's our entire diet is made up of foods that never, quote unquote, naturally would have found its way into this form. And that's driven. But of course, like you said, there's not a corner on the planet where organisms haven't, at least passively, been profoundly changed by our activities.
I think that's absolutely right. And the more we look, the more we see this. One of my favorite stories that I came across was about the little yellow-footed mice, which are the mice that live in the various parks in New York. And over 100 years ago, when the Big Apple was just a tiny seed, these little mice lived in a big, continuous, well-mixed population, and they were one type of mouse. They were genetically varied. And then the city began to spring up, and the streets and the shopping malls began to divide the mouse's natural habitat into smaller and smaller portions until they became isolated in the city's parks. And so what you see now is that the mice that live in Central Park are genetically distinct from the ones that live in Queens, which are genetically distinct to the ones that live in the Rockaway Peninsula. So they've all been evolving in their own little ecosystems in slightly different directions because the conditions in the park were all slightly different. And then the story gets even better because when you start analysing their genomes in more detail, so their genetic makeup in more detail, and you look at the little mice that live in Central Park, it turns out they have a couple of really unusual mutations in their DNA. So they have a couple of genetic variants, and one of them seems to help them process fatty food better. And the other one seems to help them neutralize a toxin that is found in a fungus that grows on moldy peanuts. So the take-home message here is rather beautiful. These mice have been evolving to eat pizza and peanuts, in the last 100 years. So on the one hand, I kind of am torn between this very big narrative of environmental disaster and extinction. And on the other hand, I'm absolutely enthralled with the life forms who are changing, who are trying to beat us at our own game, who are reacting, who are evolving. And there are loads of stories like that out there. And I just think, it conjures up this rather beautiful image of these little mice going, you know what, pizza's not so bad after all. We can cope with pizza.
Right. It's like the birds in Mexico City that they found were lining their nests with used cigarette butts. Yeah. And they found that, it seems to have some sort of anti-parasitic quality. If the cigarette has been smoked, it's much more capable of killing off parasites than an unsmoked cigarette. So they're learning and they're adapting. And I think the issue that we often don't do well in terms of like our own processing power is to think about these things as systems and to think about like a great homeostatic system that's always in ebb and flow. And like it really can adapt and change and bounce back to a point. But then when you push the system too far and when you take it out of the realm of its ability to bounce back. It's kind of like when your air conditioner breaks. or when it's just so hot that it can't cool your house quickly enough. Any of these like homeostatic systems can be pushed beyond their limits. And that's really what we're doing. We're at a breaking point for many of these organisms because we're just putting too much pressure on them far too quickly.
I think that's absolutely right. And I guess the other thing that we haven't really touched upon is about 100 years ago, there was this new discipline that emerged of conservation. It's quite a new discipline. And of course, what conservation does is it also is rerouting the evolutionary trajectory of species, but in a very positive way. So again, looping back to the beginning of the conversation, I mentioned about how, through conservation, through sort of simple strategies like habitat management, anti-poaching strategies, and increasingly through these kind of high-tech genetic and stem cell approaches, what we're learning there is that, we think of conservation as just a tool, basically, but this is about unraveling the complexities of ecosystems and understanding the interconnectedness of life. And we have this toolkit that we can use to try and make things better. There's been a huge amount of interest in recent years about something that's been called rewilding. And rewilding, I love, because I'm sure you're familiar with it. Rewilding, at its essence, is an excuse for anyone to really have a messy garden, which I love. And it's the idea that, if you give nature the space to thrive, if you let natural processes connect, if you let the component parts of an ecosystem gel and you let natural processes kick in, the environment can do a great deal to heal itself, and ecosystems can do a lot to heal itself. And there are a number of projects around the world that are demonstrating this, and that conservation can be targeted and focused, but it can also be really laid back and hugely cost effective. And what we're seeing as more and more places are starting to rewild their land, there's a really amazing example of this in the south of England, where a failing agricultural farm, the couple who run it, Isabella Tree and Charlie Burrell, they decided they would give it back to nature and see what would happen. And they now have the most amazing hybrid wildlife reserve organic farming business, where they are seeing endangered species thriving, species that we haven't seen in the UK finding their wild patch and living in it. And what we're seeing is that by letting go, by easing off the pesticides and the antibiotics, by not raising animals intensively, by letting them graze and forage. By doing that, they're actually creating habitat for wild animals to live in. So one of my favourite stories from there, and I mentioned I'm a moth and a butterfly girl. There's a butterfly in the UK called the purple emperor, which is stunning, right? And it's been in trouble for years. It's this vibrant, beautiful sort of metallic purple butterfly. And there were very few places where it was. And at this rewilding site in the south of England, what they realised, they had a couple of Tamworth pigs, so this beautiful russet pot-bellied pig, which they don't keep to sell or for meat. They keep it because it snuffles around in the ground and it creates habitat for other animals. And one of the things it does is it allows the purple emperor's food plant to grow, because to germinate, this food plant needs freshly turned land. And they didn't set out to entice the purple emperor back into their wild area. It came because they let pigs act like pigs. They let pigs be free and rootle around in the earth and churn things up with their muddy trotters. And as a result, in the little dents in the earth that they created, these saplings grew. And then the purple emperors found the saplings and they laid their eggs there. And they now have the most thriving and abundant population of these butterflies in the country. And so, sort of bringing this round to a positive end, I have a huge amount of hope that we're beginning to realise that actually it doesn't take much to steer evolution onto a much more positive footing. It doesn't take much to encourage a little bit of wildlife back into your land and to try and redress this balance between domestic and wild. So, on their patch of land, again, I said earlier on that, if you look globally, what you see is that 4% of the world's biomass is wild. On their patch of land, I would imagine that statistic is very, very different indeed. And what they have is a thriving business. They have an amazing kind of glamping site there. And they have just this long list of wild animals, endangered species that are coming back and thriving because they are taking their foot off the pedal, and they're letting the land be wild. And what you're seeing is that these ecosystem processes sort of connect back up again. And sometimes we just need to garden a little bit less, I think, and there are really positive things to come from that.
Yeah, I think it seems like there's really this like big spectrum all the way from this more passive, just kind of letting go, ripping out your lawn and letting the things that would have grown there, like the native wildflowers grow, all the way to very specific and precise, conservation technology where we're using very high-tech tools to try and understand, what's in the animal dung to know what they're eating and how they're thriving. And so everywhere in between, it seems like there's room for us to do good. And the issue is whether or not we have the will and the interest and the wherewithal to do that good, because we can, yes, act at a very local level within our own gardens. I don't even have any green space, but I have a roof deck, and up there on my roof deck, I have a hummingbird feeder, and the hummingbirds come to the fourth floor to drink nectar. You know what I mean?
So amazing.
It happens. And so everything from something small like that all the way to a large project that involves geotagging and tracking and hundreds of scientists, all of these things have the potential to do good. And I love too that your book really doesn't just focus on the horrible, I mean, that's one thing that I would love to ask you before we go is just, when you're approaching a topic like this, how do you balance between talking about how just everything sucks, but then also saying, no, but there's hope, and we've got to really be, persistent in this, and we have to give enough of a shit because this can get better if we all work together.
Yeah, I didn't want to set out to write a book that was pessimistic because I'm not a pessimistic person. And I wanted to set out to write a book that was interesting and motivating and joyful and funny to read in places. I think there's you can always find humor when you look for it. And I was surprised at this scale of the human influence that I found. I was surprised at the diversity of animals and the number of different stories that I ended up telling. But ultimately, I wanted to finish on a positive note. I think we have become curators of the planet that we find ourselves ultimately in charge of. And there are lots of great examples of people doing it well. Another favorite of mine, I think I did a whole chapter on it in the book, was this brilliant dumpy green parrot in New Zealand called the kakapo. And it's a perfect example of everything that we've been talking about. So this is an incredible bird, like a large obese budgie with an identity crisis. So it has wings, but it can't fly. It's a parrot, but it's nocturnal. It makes loads of noises, but none of them sound like a bird. So it brays like a donkey and it purrs like a cat. And then sometimes it booms like the bass line of a house music anthem. And in 1995, there were just 51 of these birds left. And the reason it took such a nosedive, I mean, there used to be hundreds of thousands of them, was because of invasive species. So when humans came to New Zealand in the various waves that came, they brought all manner of invasive species. And they decimated the kakapo what were there. And now there's been this sort of incredible conservation effort that is completely driven by science. And it's a mixture of this low-tech conservation that we talked about and the high-tech conservation. And I love it now because I think it's like we have a TV show over here called Love Island. Do you have Love Island?
I don't think we do.
So Love Island is this TV show. It's not something that I watch, where basically loads of sexy human singles get sent to live on a hot island, and they're like wired up with cameras, and everybody vicariously watches their every move to see who gets with who. And the kakapo in New Zealand are like a bird-like version of Love Island. So they've all got names, these birds now. They all wear backpacks fitted with transmitters. So we might not be filming them, but we can tell where they are at any point. If they've had an encounter with a member of the opposite sex, it gets logged, it gets scored. And the reason that people are going to this amount of trouble with these birds is because they were down to only 50 birds at one point in time. They're very, very inbred. So they're hoping that they breed naturally, but one of the worries is that some birds aren't breeding at all, others are becoming overrepresented in the breeding population. So by monitoring them this closely, they spread out the birds on different islands to try and mix up the gene pool as much as they can. And they are intensively managing this species. They are micro-managing this species. And in this case, they couldn't have just rewilded the land and let the kakapo get on with it, because this is quite a fussy, difficult bird. But the result is they had the best breeding year ever in the last breeding season. And they're now up to about 200 birds, which doesn't sound like much, but that is the largest number of kakapo we've had on the planet in a considerable amount of time. And the reason that makes me happy and that makes me smile is that this is just down to humans caring enough about one species, this big, fat, overweight budgie that lives in New Zealand, caring enough that when all the odds were turned against it, they went, right, okay, what else can we do? What else can we do? So they do artificial insemination on these birds. This year they used drones. So they'd collect semen from one bird on one side of the island. They'd use remote drones to fly the semen to a female on the other side of the island so they could inseminate her. And then sort of, again, coming full circle, we were talking about genetic modification. Well, they don't have plans to genetically modify these birds, but what they have done is they've taken blood samples from all of the adult birds and they have decoded the full genome, so the full genetic recipe for every single adult bird, right? Imagine that. There's only one other species this has been done for. So they have the full genetic makeup of every single adult bird. And as a result, they can do better pairings of animals. They can start to learn more about the evolutionary future of this bird. How much of a genetic bottleneck did it get into? They can learn about how related or not the birds are. They can learn about some of the health problems that these birds are having, whether some of them have genetic variants that might make them more fertile, for example. And as a result, because these scientists never gave up, there's a scientist called Andrew Digby who is just phenomenal, and he leads this project. This bird is coming back from the brink, and so we can change evolution for the better. Sometimes all it takes is a bit of letting go and a bit of messy gardening. But sometimes if there are species that we really don't want to lose, like the northern white rhino, like the kakapo, as a species, we can do remarkable things. We can screw up the planet on a monumental scale, but we can also do remarkable things in terms of getting species back on a decent evolutionary footing. The technology that we have at our fingertips, the ability to decode DNA, to use these high-tech reproductive techniques like artificial insemination, we can do good with this. And this is one of the things that I sort of took home from the book, is that for every sad story you come across, I think there are arguably far more stories that make you smile and that bring hope. And that's kind of what I've really enjoyed looking into this.
Yeah, I think that you, the listeners of the show, can hear stories similar to that in a few of my different episodes. Some people, might be pretty familiar with the story of the pumas, the mountain lions, the cougars. It's all the same thing here in Los Angeles, where we were very concerned about our cat population. We still are, going the way of the Florida panther, which had become quite inbred. But LA is this, I love this. We are one of 2 cities in the world that is a large urban city that has a big cat dwelling within the city limits, which I think is so cool. It's like us and the leopards of Mumbai. We've got our mountain lions and they've got their leopards. And we have a very famous cougar that lives in Griffith Park named P22, Puma 22. All of our pumas that have been found and tagged wear tracking collars. They have names. There's a great initiative by a wonderful woman who I've interviewed on the show, Beth Pratt, who works for the National Wildlife Federation, who has kind of cataloged a lot of these, what we call the cougars of LA, and like people know about their personalities and they can follow them. And all of this really great press, helping them develop these personalities and have these internet presences. They have, Twitter handles and Facebook pages and things, has actually helped raise the millions of dollars that are necessary for us to finally start the work towards putting in a wildlife crossing, a green belt that goes across the freeways to help connect these large roaming areas so that these big cats are not separated genetically from one another, but are able to breed across what we think of as these islands that have been created artificially by freeways. Because the leading cause of death amongst pumas is other pumas. They require a large roaming area. Male pumas will kill other male pumas if they're in their region. But the second leading cause of death is traffic, automobile collisions. And so you see these beautiful programs that they require, ingenuity, but really more than anything, they just require people knowing about it and wanting to affect change. And I think, as you mentioned with the birds, and as I mentioned with the cats, sometimes it takes people understanding the plight and also feeling a very personal connection to these organisms. So in that way, not to open up a whole other line of questioning, because I think we need to wrap it up, but in that way, I'm hopeful about some of our more charismatic species. I'm sometimes nervous about some of our, quote, less charismatic species, like certain types of insect, the uglier animals or the animals that don't have like the cool, personalities, because I worry that people just don't care about them as much. It's a complicated issue, obviously. And I think that your book does such a brilliant job of tackling this issue with hope, with humor, and really with a positive outlook. And so on that note, Helen, I was hoping I could close the show by asking you the same 2 questions that I ask all of my guests at the end, which are these kind of big picture questions. And I'm definitely interested to see how you answer them. You game?
Yeah, go for it. Sure.
All right. So when you think about the future in whatever context is relevant to you right now, so this could be informed by obviously the book that you wrote, life-changing. It could also be informed by your personal life, by what's going on in the world right now, just really any context. I'd love to know, on the one hand, what is the thing that keeps you up the most at night, that you're most concerned about, potentially pessimistic, maybe even cynical about, what is not looking good. But then on the flip side of that, what are you optimistic and hopeful and, authentically, really genuinely looking forward to?
Oh, wow. Okay. What keeps me up at night? I'm a parent. What keeps me up at night is my children being happy and being happy, being healthy, and having a world that they want to grow into. So I guess, the through the eyes of a parent, but with the sort of brain of a writer, I worry about the way our natural world is going. Genuinely, this is something that causes me great concern. But the flip side of that, and answering the second part of your question, what makes me optimistic? My children, the next generation, because to them it is a no-brainer that we should be eating less meat. That we should be, if so, I have a 15-year-old daughter and I have 12-year-old boy-girl twins, and they haven't been to school for months because of the lockdown. But when they were at school, if there would have been a kid screaming because there was a spider in the corner of the room and trying to stamp on it, which would happen, my daughter would scoop it up and put it outside somewhere where it would be safe. Now that warms my heart. It's not something I've ever told her to do or specifically taught her to do, but it is, a kind of an atmosphere, an ethos from the family that we live in, the way that we live our lives. And so what makes me optimistic is that, the next generation, provided we haven't left that, provided we're not too close to these tipping points that scientists keep talking about, where we end up with runaway climate change and, we don't want to resort to de-extinction. Let's be honest here. It could be a useful tool occasionally, but what we want to do is stop species going extinct in the first place. I'm quite clear about that.
Right. An ounce of prevention is worth a pound of cure. Like it's way too expensive and intensive to do that.
Yeah.
If we even can.
Far better to not let them go extinct. So I worry about not leaving a good enough future for our children. I worry about the planet being too far gone, but the optimist in me says that's not the case. And the scientist in me, the person who speaks to scientists for a living, tells me this is not the case at this point in time. And we've got this motivated, beautiful, brilliant generation coming along behind me. And I hope they make a difference. I hope they turn things around. I hope they prioritize health and happiness and the natural world over economic growth and GDP.
Right.
That's what I hope, and I am optimistic when I see things like the Extinction Rebellion movement that we had over here. Did you have that in the US?
Mm-hmm.
This kind of of course.
Yeah.
And Black Lives Matter. We have brilliant people motivated for all the right reasons to make things change, to change the world for the better, to say, I'm not going to take the way things have been handed to me by the generation above me. We need to do things differently, and we need to do things differently now. And that gives me hope. That really does.
Absolutely. Well, gosh, guys, the book is Life-Changing: How Humans Are Altering Life on Earth. Helen, thank you so much for joining me today. I learned an awful lot from you.
And I learned so much from you, and thank you so much for having me. I'm going to go and find out all about the amazing pumas of Los Angeles now.
Yay! I love that.
I'm going to dig up your podcast.
Love it. And everyone listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.